Continuation of chapter 7, that is DC to DC converters. In the last session I discussed about what exactly buck boost converter, that is buck boost regulator or up down chopper in both continuous and discontinuous mode. Okay. See, one more concept based on this buck boost regulator is, what is the expression for average output voltage as a function of internal resistance of inductor. That is, output voltage of buck boost converter, you write this one, output voltage of buck boost converter, buck boost regulator, as a function of internal resistance of inductor, as a function of internal resistance of inductor, internal resistance of inductor. This is practical case. Output voltage of buck boost converter or buck boost regulator as a function of internal resistance of inductor. This practical conditions. Yes. First you draw the circuit. You know this what circuit of buck boost regulator. And this is input voltage is VDC. This is switch. And this is inductance, and the resistance of inductance is small r. This L, this is small r, internal resistance of inductor. And this is diode. This capacitor. Let us assume that it's a resistive load. Positive, negative V0. This is I0. This is IC. This is capacitance. Voltage across the capacitor is VC. Okay. And this is diode. The current through the inductor is IL. The voltage across inductor is VL. Okay, this is chopper or switch. This may be chopper or switch, where small r is internal resistance of inductor. Okay. Internal resistance of inductor. Yes. One operation is nothing but a one on and one off. Can you try for chopper or switch is on? Chopper or switch is on. Then what about diode? Diode is under off state. Chopper or switch is on, then diode is off state. Then what is the equivalent? Inductor storing the energy. Inductor storing the energy. Storing the energy. Okay. Then you write what the equivalent. Chopper or switch is on. Inductor storing the energy. The resistance of inductor is smaller. This is IL. Positive negative VL. And this is VDC. The supply voltage is VDC. Diode is off state. This capacitor. This is IC. And this is I0. R. Positive negative V0. Okay, this is equivalent circuit. Then according to KVL, what you write? VL plus IL into small r equal to VDC. Then what is VL equal to? VDC minus IL into small r. Okay. This is according to KVL. Where capital R is load resistance. Load resistance. Okay. Then what is KCL, you tell me? Then according to KCL, IC plus I0 equal to 0. Then what is IC equal to? Minus I0. Okay. But one operation is nothing but one on and one off. Then chopper is or switch is off. Chopper or the switch is off. Then what about the diode? Diode will on. What is the equivalent? If the diode is on, inductor releasing the energy. The internal resistance of inductor is smaller. This is L. This DC voltage is VDC. Okay. Diode is on, inductor releasing the energy. This is IL. Okay. And this one is capacitor. The resistive load is R. This is I0. And this is IC. And this is IL. Chopper or switch is off. Sorry, this is off state. Chopper or switch is off. Now inductor will conduct like this. Okay. Positive, negative. No need of this representation. Positive, negative VL. Then inductor will reverse after reversing the polarity. No doubt at all. Okay. Then apply KVL here. Positive, negative V0. Or the KVL plus minus V0. That VL equal to V0 you get. This is KVL. What is KCL? This is IL, this is IC, this is I0. IL equal to, sorry, 1 minute. VL, this one, here we have the resistance of inductor also there. Then what you can get? VL plus, this is V0, na? V0, then this is plus minus. Okay, what you get? V0 is equal to VL plus IL into R. Then from this, what is VL equal to V naught minus IL into R. This is VL equal to V naught minus IL into R. This VL plus IL into R is equal to V naught. This voltage is equal to this voltage because it's a parallel. Now you tell me, what is KCL? If you apply KCL, then what we get? IL equal to minus of R. We get IC plus IL plus IC plus I naught equal to 0. Then what is IC equal to? Minus of IL plus I naught we can get. Clear? IC equal to minus of IL plus I naught. Then to derive the formula, go for volt second balance. Then what is the volt second balance? Volt second balance. According to volt second balance, how we can write? VL on into T on plus VL off into T off is equal to 0. VL on into T on plus VL off into T off is equal to 0. What is the on state voltage? VDC minus IL into R into T on plus what is VL off? V naught minus IL into R. V naught minus IL into R is equal to into T off is equal to 0. It's correct. Shall you write like this? VDC into T on minus ILR into on is common. Then what we get? T on plus T off is equal to, you bring this side V naught minus V naught into T off minus V naught into T off. Is correct? Then shall you write like this? VDC into T on. T on is written as dt. dt minus ILR into T on plus T is T. Minus V naught into T off is 1 minus D into T. Then TT cancel. What you get? dVdC equal to dVdC equal to what you get? dVdC equal to IL into R plus IL into R minus V naught into 1 minus D. Let this is equation 1. Okay. Then what about current second balance? Then according to current second balance, ampere second balance. If you apply ampere second balance, what you get? You tell me. According to ampere second balance, IC on into T on plus IC off into T off is equal to 0. Okay. Then from this, what is IC on? Minus I naught into T on plus what is IC off? Minus of IL plus I naught into T off is equal to 0. Then you simplify this. What you get? You tell me. Yes, you simplify that. What you get? Minus I naught into T on minus of IL plus I naught into T off. Okay. Then I naught into T on is equal to minus of IL plus I naught into T off. Okay. What is T on? You write dt. minus of IL plus I naught into, what is T of you write? 1 minus D into T. This TT cancel. We want to find the expression for IL now. What is the expression for IL? Then I naught into D, you bring this side, plus I naught into 1 minus D is equal to minus IL into 1 minus D. Then DD cancel, what you can get? IL equal to minus I naught by 1 minus D. This is expression for IL. Let this is equation 2. Yes, or hold on quick. Now substitute equation 2 in equation 1. Substitute. Okay. Substitute equation 2 in equation 1. If you substitute equation 2 in equation 1, then what you get? Tell me. D into VDC is equal to, what is IL? Minus I naught by 1 minus D into small r minus V naught into 1 minus D. Yes. But you want to get expression for V naught na? V naught in terms of VDC you want to write. Shall you write like this? dVDC. I naught is written as V naught by R minus V naught by R into 1 minus D into small r minus V naught into 1 minus D. Then dVDC is equal to, take minus V naught is common, small r by capital R into 1 minus D plus 1 minus D. It's correct. You simplify this. Over. S. What you get, you tell me. You simplify that. dVDC equal to minus V naught into small r by capital R plus 1 minus D whole square by 1 minus D. Then what is V naught equal to? Minus D into 1 minus D into VDC by small r by capital R plus 1 minus D whole square. This is expression for average output voltage. You substitute small r equal to 0, then 1 minus D cancel, then you get dVDC by 1 minus D. Same that of without internal resistance of inductor, we get same formula na, by substituting small r is 0. But this is negative sign because inductor current is opposite to load current. Inductor current is opposite to load current. That's why you are getting that expression. Then you write this one without any negative sign, mainly you take, this is V naught equal to VDC into D into 1 minus D into 1 minus D by small r by capital R plus 1 minus D whole square. This is the expression for average output voltage. Then no need in the calculations, no need to take negative. The reason for negative sign that you know. VDC into D into 1 minus D by small r by capital R plus 1 minus D whole square. Okay, this expression for average output voltage of buck boost converter by considering internal resistance of inductor. Quick note down. Where the average output voltage is maximum. Where the average output voltage is maximum. To get the condition for maximum average output voltage. Maximum average output voltage. To get the condition for maximum average output voltage, differentiate average output voltage with respect to duty cycle and equate to 0. You differentiate this average output voltage with respect to duty cycle, then equate to 0. Then at a value of D equal to 1 plus small r by capital R minus square root of small r into 1 plus small r by capital R by capital R. At this value of duty cycle, this is called Dmax. This is called Dmax. That is a duty cycle at a maximum average output voltage. Note down this. This is the value of duty cycle at which average output voltage. At which maximum average. Duty cycle at maximum average output voltage. Duty cycle at maximum average output voltage. Average output voltage. Then what is the value of maximum average output voltage? Then what you can do? Substitute Dmax in V0. Then we get the expression for maximum average output voltage. Then V0 max equal to, then what is the expression for VDC by 2 into square root of 1 plus capital R by small r minus 1. This is the maximum average output voltage. How to get this value means substitute this value in this equation. You substitute this value in this equation, then you can get maximum average output voltage. This is maximum average output voltage. Maximum average output voltage. Average output voltage. Then if you draw the characteristics by considering both the equations, if you draw the characteristics, what you get, you tell me. By considering internal resistance of inductor, what is V0? VDC into D into 1 minus D by small r by capital R plus 1 minus D whole square. This you know. Then without small r, you tell me what is V0 equal to D into VDC by 1 minus D. Tell me. In this case, for D equal to 0, for duty cycle equal to 0, what is V0? 0. Here also, for D equal to 0, what is V0? 0. In both, with small r, without small r, in both the cases average voltage equal to 0 for D equal to 0. For D equal to 1, what is V0? 0. Here for D equal to 1, what is V0? Infinity. But practically it is not possible. This is practical case. This is practical. Now with this knowledge, if you draw this one, character 6 for this one, okay, it's over, okay. Then if you draw the character 6, V0 versus duty cycle, to draw the character 6 between V0 versus duty cycle, then what you get, you tell me. You draw the character 6 between V0 versus duty cycle. This is V0. This is duty cycle. Both are started at D equal to 0. This is 0. Then at D equal to 1, ideally it is infinity. Ideally it is infinity. But what about practically? Then practically we can get like this. This is ideal case. Okay, this is for D max. We get like this. Okay, this is D max. And this is unstable operation. Practically this is unstable operation. We never operate for greater than D max. This is for practical case. But if substitute D equal to 0.5 here, if substitute D equal to 0.5, what you can get? V0 equal to VDC you can get. This is for D equal to 0.5. We get V0 equal to VDC. For D equal to 0.5, you can get V0 equal to VDC. Even in the ideal case also. For D equal to 0.5, V0 equal to VDC. Point to remember, and this is operation for buck regulator operation, and this operation for boost regulator operation. Boost regulator, and this is unstable operation. Okay, this is ideal case. Ideally, for D equal to 1, this is infinity. For D equal to 1, this is infinity. Okay, these are the observations from based on this character. That means practically the buck regulator will operate 0 to 0.5. Boost regulator will operate 0.5 to D max. What is that D maximum value? 1 plus small r by capital R minus square root of small r into 1 plus small r by capital R that equal to D max. This about analysis of buck boost regulator by considering internal resistance of inductor. Okay. Can you down quick? Then what this value? This value is maximum value. This is V max. For D corresponding to D maxima, we can get V naught maximum. Over. Now we write a summary formula with respect to buck boost converter. This is summary I'm giving with respect to buck boost regulator or up down chopper. Buck boost regulator or up down chopper. Buck boost regulator. Or up down chopper. First one is, what is the average output voltage? Average output voltage equal to, this is dVdC by 1 minus d, without considering any internal resistance, and it is a continuous mode. Then what is average load current I naught equal to V naught by R? Then what is I naught equal to V naught minus E by R? This is for R comma RL loads, and this is RE comma RLE loads. Okay. Then you know this, for 0 less than D less than 0.5, this is buck regulator. For 0.5 less than D less than 1, this is boost regulator. Second one, what is IL average equal to? IL equal to I naught by 1 minus T. I am not considering any negative sign here. Generally it is a I naught by 1 minus T. Third one, IS average equal to I naught by 1 minus T. IS average equal to we can get I naught by 1 minus. This formula you derived. What is the average source current based on input and output power. Then peak to peak inductor ripple current dVdC by FL. It is maximum at D equal to 1. Next, fifth one, what is IL max? IL max equal to IL plus delta IL by 2. What is IL minima? IL minima equal to IL minus delta IL by 2. Sixth one, you tell me, what is average value of switch current? Average value of switch current equal to DIL. What is the RMS value of switch current equal to root DIL? What is the peak value of switch current equal to IL max? What is the peak value of switch voltage equal to VL plus VDC? Seventh one, what is the average value of diode current equal to 1 minus D into IL? What is the RMS value of diode current equal to square root of 1 minus D into IL? Eighth one. Yes. Can you tell me what is the peak to peak capacitor ripple voltage Di naught by Fc? Then it is maximum at D equal to 1. What is the value of critical inductance? The critical inductance equal to R into 1 minus D whole square by 2F. What is the critical capacitance? Cc equal to D by 2Fr. Corresponding to this is critical resistance. Corresponding to this one, this also critical resistance, D by 2Fr. In discontinuous mode of operation, what is the value of average output voltage in discontinuous mode? The average output voltage in discontinuous mode is D by beta minus D into VDC. In discontinuous mode, IL max equal to delta IL. V naught in discontinuous mode is always greater than V naught in continuous mode. V naught in discontinuous mode is greater than V naught in continuous mode. 12th one. By considering internal resistance of inductor, by considering internal resistance of inductor, internal resistance of inductor, internal resistance of inductor. Can you tell what is V naught equal to? VDC into D into 1 minus D by small r by capital R plus 1 minus D whole square. This is average output voltage. Then by considering internal resistance of inductor, what is D max equal to? That is duty cycle at maximum output voltage, maximum average output is equal to 1 plus small r by capital R minus square root of small r into 1 plus small r by capital R by capital R. Then what is the maximum average output voltage by considering internal resistance of inductor? VDC by 2 into square root of 1 plus capital R by small r. Yes, you write 1 plus square root of capital R by small r minus 1. Quick, note down this. This is summary of buck boost converter. If you want to answer any questions based on buck boost regulator, then you concentrate on these formulas. Yes, here I am giving one note. We know that at boundary in buck regulator, boundary means at critical, what is the critical inductance LC equal to? Critical inductance LC equal to, in the case of buck regulator, what is the critical inductance we calculated? R into D into 1 minus D by 2F. Okay, this known R into 1 minus D by 2F. R into 1 minus D by 2F. This is a critical inductance. Then from this you take 2L by RT equal to 1 minus D. This we are assuming that this is K and this is KCR. In boost regulator, what is LC equal to? R into D into 1 minus D whole square by 2F. 2L by RT equal to D into 1 minus D whole square. We assume that this is K and this is KCR. Just some constant we are assuming. In buck boost regulator, what is LC equal to? R into 1 minus D whole square by 2F. that is L by 2L, that is 2L by RT, instead of LC taken RT, is equal to 1 minus D whole square. This you take K and this is KCR. In any case, if K greater than KCR, in this one, if K greater than KCR, which mode? Continuous mode. If K equal to KCR, just to continuous. If K less than KCR, then it becomes discontinuous mode. This is discontinuous mode. If K is less than KCR, then it is a discontinuous mode. What is the K here? Conduction parameter. We are assuming some constant only. What is KCR? Critical value of parameter. Okay. Then if K conduction parameter is greater than critical value parameter, then we can say that is a continuous mode. If it is less, then it is a discontinuous. If K equal to KCR, then we can say just continuous. But I already told that the another way to analyze, is it a continuous mode or discontinuous mode? If L given, you also write like this note. If L given is greater than LC or critical inductance, then it is a continuous mode. If L given less than LC, then it is a discontinuous mode. If L given is equal to LC, then it is a boundary or just continuous mode, or just continuous. This is just like this also we can analyze, just continuous. Okay, then given circuit either continuous or discontinuous, how to analyze? Like this also we can analyze either continuous or discontinuous, or by calculating these parameters also we can analyze either continuous or discontinuous. Okay, now down.